Okay. All right. So while we're waiting for folks to come in, I want you to go to Canvas and look at energy flow and nutrients off the other day. All right. And most specifically, we watched the video on um, the hydrologic cycle. And I want you to just review these different cycles. We're going to watch some videos today on the nitrogen cycle, phosphorus, and water cycle as a review. So just familiarize yourself with these definitions today. And then we'll do, on Friday, we'll do a quiz on the importance of these cycles. Now I have embedded the PowerPoint that I'm going to show you, so you'll be able to replay it and study it. Okay, we got a good number of folks are already logged in. All right, so take a look at that. I'm going to go ahead and do attendance while you are reading this page. So again, I'm going to stop sharing. So everybody needs to be in Canvas. You're on the unit that says EFE, flows of nutrients in the ecosystem, and you need to be looking at before you go, you need to know. So we're going to look at these cycles today. And I need to add. So we're going to look at the water cycle, phosphorus cycle, and nitrogen cycles today. Probably look at carbon another time. Excuse me. All right, so you look at that. I'm going to stop sharing. I'm going to do attendance and get GoGuardian started. And then we'll get started. All right, I do want to say, as I said to my last class, I've had some folks who log in, and then when I look at GoGuardian, it says it's been idle for 20 minutes. If you've been idle for 20 minutes, that means you're not participating, you're not looking, the computer's just on. And usually when I check, I'm looking at your ceiling, you're not involved. When I see that, I'm either going to mark you absent or mark you tardy. So you need to actually be on camera and you need to be doing the activity um, that the class is doing. Your computer, when I look at GoGuardian, it shouldn't say a student's been idle for 20 minutes. Okay, just a heads up. I do attendance by looking at GoGuardian. So if I see offline, that means you're absent. And when I look at GoGuardian, I shouldn't be looking at me. I should be looking at everybody right now should be in Canvas and they should be looking at the vocabulary words, not looking at me, which is what I'm looking at. At least 6 of y'all are looking at the screen and have not logged into Canvas yet. Ethan, why am I looking at you? All right, so again, there's about 5 of y'all who are not where you should be. And that tells me that you're logged in, but you're not prepared to start class. Everybody should be in not energy consumption, Jalen. You're in the wrong one. You should be in EFE, and everybody should be on flow of nutrients, flow of nutrients, flow of nutrients. Everybody should be on flow of nutrients. And again, there's about 5 of you who the screen is showing me, and it should be showing you in. Okay. Ethan, I thought you were in already. Why is it still saying join? All right. So if I'm looking at me, I'm not marking you absent yes, but I'm gonna come back and check to make sure that you are indeed looking at what you're supposed to be looking at. So I got Tegan, Nevaeh, Lucas, Aaron, Jaquise, all y'all looking at the screen. Ethan, looks like you're having some trouble with your internet. Alrighty. And Lucas and Tegan already is telling me you've been idle for 10 minutes. Okay. All right, Ethan, I hope you get straightened out. Let me very quickly do attendance. Like I said, I reserve the right to go back and mark you non-participating if your screen is idle. Oh, that's not what I wanted to do. I want this one. Okay, so back over here. Okay, good. Ethan, you finally got in. Good job. Okay. All right, so again, everybody should be looking at the vocabulary on that page. I think some of y'all are having internet problems today because people who are in all of a sudden pop out. Okay, come back over here and share. Okay. All right, I'm going to share. A lot of you, if you just came in, you don't know where we are. Thursday, somebody said you were taking a test on Thursday. Okay. You, and is that a question? Are you asked, are we taking a test on Thursday? Yes, on the cycle. So I want you to pay attention to the cycles that we're doing today. Okay. So, and the test will just be on the cycles. So just stay with me on the cycles. All right, somebody's mic is open. Somebody have a question? All right, so let me pull up the share screen again so that everybody, because some of y'all came in late, so everybody knows where we are. All right, and I'm showing a PowerPoint today, and you need to be logged in. I embedded the PowerPoint in the module so that everybody can see it and save it and study it. And it has some extra things in it, but we're going to focus more on the cycles today. Okay. All righty. So again, yes, we are having a quiz tomorrow. I believe this is going to be the last one before the 9 weeks reports go out. So make sure that you are one, present, and two, that you're paying attention to videos. All right, so just backing up, we've been talking about energy flowing. Let me totally back up. All right, we've been talking about energy flowing through an ecosystem, and um, so we looked at food chains and food webs. We know that the energy starts at the bottom, and that's why it's the widest. That and there are the producers are always at the bottom. In this case, they're just calling them plankton in general, but mostly the phytoplankton, which are the plant type microscopic organisms, they're at the bottom. This picture also has included the zooplankton, which are also going to be at the bottom because they're small, but they don't photosynthesize. So the zooplankton don't photosynthesize, the phytoplankton do. So that's where photosynthesis is occurring. You need to make sure that this pyramid is about the flow of energy. The eating patterns is about who eats who. The original energy from the sun is absorbed by producers and then consumed by your primary consumers, which are always herbivores. And then you have the other organisms that eat the herbivores, and some eat both plants and animals. And so the energy flow goes from plant, in this particular case, grasshopper to bird to snake to owl. That's a food chain. Then you have to be familiar with a food web. The difference with a food web is it considers that in a particular ecosystem, and you got to remember there are different kinds of ecosystem. There's desert, there's Arctic, there's terrestrial, there's aquatic, and so your producer is going to be different in each of those systems, and the organisms that feed on those will also be different. This particular example is a terrestrial ecosystem. So you have trees and shrubs and grass. And so you're looking at the animals that are involved in that. And remember that a food web is a broader view of all of the feeding relationships in that particular ecosystem. Okay, so if, for example, one organism is missing, then they have a choice of eating something else. Okay, they might not go extinct because one thing is missing. The other thing we need to remember is the 10% rule, that each organism is only passing on 10% of the energy because it used the other 90% for respiration and growth and repair, reproduction. All of those activities require energy. So it eats or makes its own food. In case of producers, it feeds and then uses 90% of the energy, so that when it is eaten, only 10% of the energy that it originally got is being passed on to um, um, the next organism that's eating it. Okay, so the 10% rule says that as we go up the pyramid, 10% of the energy is lost always. And we looked at, let's see, let me come back. Okay, this one has numbers on it, but if you look at these numbers and we take away 10%, I always say you don't have to do the math, you just simply move the decimal point. So you notice that if you move the decimal point over one for each level, it has lost 10%. So where it started with 15,200, now it's 1,520. Now the mice are only giving have stored are able to pass on 152 kilograms of energy. And then by the time you get to the snake, it's only getting 15. So on each level, it only passed on 10% of the original energy that it got from the thing that it ate. Okay. All right. So back over to what we're looking at today. So energy flows, it keeps moving from one level to another. So we're looking at this. So what I have for you is a PowerPoint, and we're going to look at just exactly what we mean by flowing. So on yours, there is the next module to yours. So can I zoom it? No, I don't want to zoom it. Okay, that's what I want to do. I want to do this. There we go. All right. So we're cycling. We can cycle carbon and oxygen, and we're going to come back to that. But what I really want to get to today is this video. Is it not going to play the video? Oh my goodness. Okay. I thought I could embed it in thing, but it's not going to work that way. Okay, I'm going to have to show it to you from my side.
I have it.
You have it? Oh,
Mm-hmm.
good. Great. Thank you. Thank you. All right. Well, go ahead. All right. So everybody should have moved on to the next one and watch that video. I can't play it here, but and tell you what I'm going to do. I'm going to just let you all go through these. There are several. There's this video. Then I want you to read the summary. Okay, let me do this. Come back up here to the thingy. Where'd it go? Oh. All right, so what I want you to do is go through this, and I only need you to watch the hydrologic cycle, read that box, and the nitrogen cycle, read that box, and the phosphorus cycle, and read this box. So you want to stop when you get to impacts of human activities. So each of these should be a video that will play for you. It's not playing for me, but it should play for you. Okay? All right, let me know if it doesn't. Jayla says you do not have the video. All right. Who was that who said they got the video?
Oh, I thought you were talking about the slides. No, the video
Oh,
won't play for me either. I thought you were talking about slides.
okay. No. Okay. So I'm going to close this and I'm going to play the PowerPoint from my side. And then that way you can watch the video. Okay. Here we go. And I thought it was. There we go.
Hey everyone, I'm Travis Bobby, joined my son, Bornis Bobby. If you're new to the channel, hit the subscribe button so you don't miss on any of our upcoming videos. Also, scan the QR code in the top left corner.
Oops, sorry.
Hey everyone, I'm Travis Bobby, joined my son, Bornis Bobby. If you're new to the channel, hit the subscribe button so you don't miss on any of our upcoming videos. Also, scan the QR code in the top left corner of the screen to contact us and explore more of our awesome content and material. In today's video, we will explain the importance of water and how it is cycled throughout the living and non-living parts of ecosystems. So let's do this.
All right. Give me a minute. See if I can't just make this take up my whole screen. He's going to start all over again.
In today's video, we will explain the importance of water and how it is cycled throughout the living and non-living parts of ecosystems. So let's do this. Our main subject for today is I can explain the importance of water and how it is cycled throughout the living and non-living parts of ecosystems. Water is essential to all living things on Earth because virtually all biochemical reactions take place in water. Water can dissolve almost anything, so it also provides an efficient way to transfer substances between and within cells. The water cycle, also known as the hydrological cycle, describes the continuous movement of water on, above, and below Earth's surface. As it cycles, water moves from one exchange pool or reservoir to another. In different parts of the cycle, water exists as a liquid in water form, solid in ice form, or gas in water vapor form. Therefore, the water cycle includes several physical processes by which water changes states. These processes include evaporation, sublimation, transpiration, condensation, precipitation, deposition.
You can't hear it?
Infiltration and percolation.
Okay, hold on.
That's a mouthful. So let's break these.
All right, nobody can hear it. Let me see if I can get the closed caption to go on. Okay. Let's see. My volume is up as high as it can go. Have you tried turning your volume up? Does it help if you turn yours up? I'll try. Okay, mine is up. Yeah, I'm gonna have to go back to the original. Okay, so we can't watch it embedded in this. Okay. Best laid plans of mice and men. Let me look at that. Let me look at. Save assist. Let me see if I do that. All right, can you still hear me? All right, let me see if going back to this, I did click on something. Let me see if this helps you hear it.
Hey everyone, I'm Travis Spivey, join my son, Gordon Spivey. If you're new to the channel, click and subscribe button to show mention on
You hear it now?
water. Sublimation also occurs
No?
because of heat from the sun. Transpiration occurs when plants release water vapor through tiny pores and leaves called stomata. Plants take up
Are you hearing it?
roots than they need for photosynthesis and other processes. Much of this excess water is given off via transpiration. Now let's move on to condensation, precipitation, and deposition. The relatively low density of molecules of water vapor causes water vapor to rise up into the atmosphere.
Okay. Hold on, let me. Um, I am not seeing a button that says, okay, give me a minute to stop sharing while I search this. All right, do you know where the button is on the Zoom that will change the volume? I think Ethan said there should be a setting in the meeting that allows you to share the audio. But when I look at the audio, it does not. All right, select speaker, test microphone, switch. It doesn't say anything about sharing the audio. Host tools. Okay. Share screen, I think it. Share screen page. Okay, hold on. Let me try the share screen page again. Share sound. Okay, I still see that button. Okay, I clicked on that. Let's see if that helps. All right, let's see if that indeed did help. Okay, I think I found it. So let's try this one.
Water vapor rises higher above the Earth's surface.
How's that?
It cools and condenses on tiny dust particles in the air.
All right. Yeah.
Condensation is the
Thank you, Ethan.
process in which water vapor changes to liquid water, forming water droplets. If enough water droplets are present, they may form a visible cloud. If the droplets become large enough, they fall to Earth because of gravity as precipitation, such as rain, snow, sleet.
All right, I'm going to switch this so that it's larger. And pop this back to.
Hey, the water cycle, it can change to the gaseous state via 3 different processes: evaporation,
Thank you.
sublimation, and transpiration. As you can see in the following diagram, these 3 processes move water into the atmosphere. Evaporation occurs when water on Earth's surface changes to water vapor. When the sun heats water, it gives water molecules enough energy to escape into the atmosphere. Water evaporates from soil on Earth's surface as well as from bodies of water. When salty ocean water evaporates, it leaves salt behind. Sublimation occurs when ice and snow change directly to water vapor without first melting to form liquid water. Sublimation also occurs because of heat from the sun. Transpiration occurs when plants release water vapor through tiny pores in leaves called stomata. Plants take up more water through their roots than they need for photosynthesis and other processes. Much of this excess water is given off via transpiration. Now let's move on to condensation, precipitation, and deposition.
The relatively low density of molecules of water vapor causes water vapor to rise up into the atmosphere. As the water vapor rises higher above the Earth's surface, it cools and condenses on tiny dust particles in the air. Condensation is the process in which water vapor changes to liquid water, forming water droplets. If enough water droplets are present, they may form a visible cloud. If the droplets become large enough, they fall to Earth because of gravity as precipitation, such as rain, snow, sleet, or hail. Most precipitation falls into the ocean because ocean water covers much of Earth's surface, close to 70% to be exact. Eventually, this water evaporates again and repeats the cycle. Some frozen precipitation becomes part of ice caps and glaciers. We call this deposition, which is when water vapor in the atmosphere changes directly into ice, such as snowflakes and frost. It is important to know that these masses of ice can store frozen water for hundreds or even thousands of years. Now let's take a look at runoff, infiltration, and percolation.
Precipitation that falls on land may flow over the surface of the ground. This water is called runoff, and it may eventually flow into a body of water. As water flows over land, it dissolves minerals and carries them across Earth's surface. Flowing water also causes erosion and deposition of eroded sediments. These processes reshape Earth's geological features. Some of the precipitation that falls on land may soak into the ground and become groundwater. This process is called infiltration. Infiltration happens when water soaks into the soil from ground level. Infiltration then leads to percolation of water, which is when water moves down through the soil. As the water percolates into the deeper layers of the soil, it reaches groundwater, which is below the surface. Groundwater may seep out of the ground at a spring or into a body of water such as a lake or the ocean. Some groundwater may be taken up by plant roots, while some of the water may flow deeper on the ground to an aquifer.
In summary, there are several components of the water cycle that cycle through the living and non-living parts of ecosystems. Without the water cycle, processes such as photosynthesis and cellular respiration would cease to exist because they both depend on water to occur. Quick question. What would occur to plants and animals if the water cycle was suddenly stopped in an ecosystem? Take 2 minutes to think, pair, and share out with your teacher and classmates. We're ready to hear all of your brilliant responses. And that's our video for today. Now let's test your knowledge to see how proficient you are with explaining the importance of water and how it is cycled throughout the living and non-living parts of ecosystems by taking our video quiz.
Use your electronic device to scan the QR code at the top right of the screen, or you can click the link in the description box below the video to take the quiz.
Remember, 80% or higher for proficiency. Record your results on your proficiency sheet, and if you don't get it the first time, you better keep going because it's not over until you win.
Don't forget to hit that subscribe button, click that bell icon, and also scan the QR code to contact.
All right. So, the importance of this cycle. Let me go back just a little bit of what. Let me see. Okay, right here. Okay. What you need to know about the water cycle. Like I said, this is more advanced than the one you probably learned in middle school, but you need to be familiar with all of the activity that's going on, the way that water goes from one phase to another. So it is going from liquid water to gaseous water. Sometimes it is solid because you might have ice. So precipitation, you need to remember, can be ice, hail, sleet, snow, rain. There's different ways that the water can precipitate down. This is a cycle, so it doesn't really matter where you start. We mostly start with precipitation. It hits the ground and two things can happen to it. It can either run off the land and run back into a body of water, or it can infiltrate the soil and then it can be deposited into groundwater reservoirs. Some of the groundwaters, as you see at the bottom, will eventually end up back into an ocean or a stream, and some of it will be taken up by the plants. Okay, so plants will absorb the water from the ground, or the water is going to end up in pockets that we call groundwater supplies, aquifers, and sometimes it leads out. Aquifers are designed to hold the water so that the city can use the water, but some of these groundwater supplies will eventually lead back into a larger body of water. And then we start all over again. We have evaporation, so it goes from being liquid water to gaseous water. So evaporation, condensation means it goes from a gas back to a liquid. It is stored in the clouds until it gets so heavy that it falls down again. So that's one way that the water goes back. The other way that it goes back is transpiration, where the plants, it's like we perspire, plants transpire. They just release the water vapor. Part of our the activity of a plant is not just photosynthesis, but it also respiration. One of the byproducts of respiration is water vapor. We exhale carbon dioxide and water vapor. So transpiration. Okay, I'll stay put. All right. Sublimation, the word sublimation means it skips a cycle. So we know that things go from solid to a liquid to a gas. In this case, the ice at the top of the mountain is a solid, and it goes immediately. It skips the water phase. It doesn't melt. It goes immediately to the clouds and becomes a gas. So that's sublimation. You skip the liquid phase and just go from ice to a gas, and is condensated in the clouds. And deposition is the reverse. So sublimation and deposition are connected to each other. It also skips a phase. So it's going to go from the gas phase straight to a solid phase. It's going to skip the liquid phase. So it's not raining for deposition. It's going from being a gas to a solid ice. All right, so I'm going to stay here a minute. Somebody said they were writing things down, and you might want to do that too. Or what you might want to do is download a picture, and this might be a little more helpful. Download a picture of the water cycle so that you know all of these vocabulary words. All right, notice there's a sun here. So the sun, again, is our source of energy. So not just for the the pyramid and food cycles. Sun is the source of energy that drives this system. It drives evaporation, it drives condensation, it drives precipitation. All right. Imani, are we good? Anybody else writing this down? Okay. All right. So we are going to, all right, so this is just a brief. Now, you might not be able to watch the video in the module, but this you can advance the slides in the module, so you should be able to see this. So it's important. Water is important for us for drinking, respiration, perspiration, elimination of waste, and all parts of this cycle. Large amounts of water are needed for most economic activities. So this is your ecology part. So agriculture, we have to water all the plants so that we can have crops to eat. Mining, if you want to mine up minerals from the ground, you need water. Food processing, all food processing plants, water is important in the system, but a lot of them, their turbines are run by water. So, and most manufacturing companies have some type of big turbine system that creates energy. And we're going to talk about those kinds of generators later on. All right, lakes and rivers provide towns and city with the means of discharging waste. Okay. So then it has to go to the water treatment plant to be cleaned up so it can go on again. All right, let's see. How much time? So now we're going to look at the nitrogen cycle. And okay. I tell you what, we won't test tomorrow because I do want to finish these. We spent so much time trying to get this started that we've run out of time. So just take a look at these. We'll start here with nitrogen tomorrow. We'll talk about nitrogen and phosphorus because I do want to also look at, we have the nitrogen cycle to look at as well. Yes, yes, Ethan, that is true. All right, let me go back here. Okay, so, all right, so I do want to do these other two videos, so we'll do this tomorrow, okay? All right, so I will see y'all tomorrow.